All right, now we're ready for section 1.5. We're still working with functions in this chapter. Now these are combinations of functions. So there's different ways to combine function. First is just by normal arithmetic process like add, subtract, multiply, and divide. And that's just like the thing says. So if it says f plus g, you're just going to add those two together. If it said f times g, you're going to multiply the two functions. If it said f minus g, you're going to subtract the two functions. If it says f over h, you're going to divide the two functions. So like here we have these three functions. There's f, g, and h. So first it says f plus g, so we're going to add f and g together. So f is 2x plus 1. G is x squared plus 2x minus 1. So you combine these and just combine like terms. So we're going to get x squared. We're going to get 4x, and the 1's cancel. So we just have that. Now here is f plus g of 2. Now when there's a number in here, that doesn't mean multiplied by 2. Remember, anything in the parentheses is what we plug in for x. So there's two ways to do this one. Most of the time, the easiest way is to plug 2 into f and plug 2 into g. So you plug 2 into each function. Well, if we plug 2 into f, 2 times 2 is 4 plus 1 is 5. If we plug 2 into g, 2 squared is 4, plus 2 times 2 is another 4, makes 8, minus 1 is 7. So 5 plus 7 is 12. Another way to do it is over here we already found f plus g. We already found f plus g was x squared plus 4x. If you already had that, you could just plug the 2 right in there. So that'd be 2 squared plus 4 times 2. 4 plus 8 is still 12. Most of the time you have not already added them, so it's easiest to plug it into both. But either way works. Here f minus g of x means that we're going to subtract. Here you have to just be careful. You're subtracting all of g. So we have 2x plus 1. If we're subtracting all of g, that means we're subtracting each one of these, so we need to change every sign. So you're subtracting x squared. You're subtracting 2x. You're subtracting a negative 1. So it's going to look like that if I change all the signs. So I have a negative x squared. The two x's cancel out, and 1 plus 1 is 2. It's easy when you're subtracting a function like that to forget to subtract all of them, so be careful. Here, f times g means we're taking 2x plus 1 times all of g, x squared plus 2x minus 1. So there you're going to multiply that out. So we're going to take 2x times all three of these. So 2x times x squared is 2x cubed. 2x times 2x, 4x squared. 2x times a negative 1, negative 2x. Now we need to take 1 times all three of those. So 1 times x squared, x squared. 1 times 2x, 2x. 1 times negative 1, negative 1. Now we combine like terms. So there's 2x cubed, 4x squared, and another x squared is 5x squared. Negative 2x and a positive 2x cancel out, and minus 1. So that's what we have there. And this is one where it's much easier, like here, when we want f times g of negative 1, is plug it into each one. Because then we wouldn't have had to do all this. If that's all they asked us was this, so we're going to find f of negative 1 times g of negative 1. So f of negative 1, we're putting negative 1 in here, so that'll be negative 2 plus 1 is negative 1. G of negative 1, if we plug negative 1 here, negative 1 squared is 1, plus 2 times a negative 1 is a negative 2, so 1 plus a negative 2 is a negative 1, minus 2, or minus 1 is a negative 2. Now we just multiply those together. This one, f divided by h, well, we just take f, which was 2x plus 1, over h, which is the square root of 4 minus x squared. Now, on most of these, you will have to mention the domain, because since we put this in the bottom, That affects our domain. Remember, with domain, whatever's in the parentheses, we talked about this the other day, whatever's in the parentheses cannot be negative. So we say that number in parentheses, 4 minus x squared, can't be negative. Well, that's all that's left is greater than or equal to 0. Well, now we solve that. So if I move the x squared to the other side, now this one gets a little tricky because when you square root both sides, you have to do plus or minus. So I'm going to write this the other way just so it's a little clearer. I'm going to move the 4. I would do it the other way, but this way maybe we'll see it better. Now when we divide by a -1, that means a cause. Remember, if you multiply both sides by a negative, we have to flip the sign. So now it looks like that. Well, now when we square root that, we have x is less than or equal to 2. Well, whenever it's an inequality like this and you square root it, you also have to do greater than or equal to -2. That's because, remember, when we square root both sides, we have to put plus or minus. Well, this is the equivalent of the plus or minus. So whenever you do one of these and you get a radical or something, the x in the bottom, you have to include the domain on those. So that's the basic ones. Now we have composite functions. Composite functions mean when you're plugging one function into another function. It's like here, this little circle means of. So this says f of h of x. This is kind of an older style. This is the style I actually prefer. These two say the same thing. Notice h of x is on the inside. You see how it's on the inside? And f is on the outside. You always plug the inside function into the outside function. This is handy with something you're going to do in calculus too, where it's important to identify the inside function and the outside function. But that's the same as this. Here, h is the inside function, f is the outside function. So when it says here, f of h of 1, first, we need to plug 1 into h. Well, if we go back up here, if we plug 1 into h, that's the square root of 4 minus 1, so that's the square root of 3. Now we need to plug that into the outside function. We need to plug radical 3 into f. So we go up here and put radical 3 in for x. That'd be 2 radical 3 plus 1. So you always plug your number into the inside function, so that's the one next to it. Then you take that answer and plug it into the outside function. Here, it's h of f of x. So that means we're plugging f is our inside function. We're plugging it into h. So f is 2x plus 1. We're going to take that whole function and put it right in there for that x. So we're taking 2x plus 1 and putting it right in place of that x there. So that's going to be the square root of 4 minus, and then 2x plus 1 squared. So 4 minus 2x plus 1 squared. So that we got that from right here. 4 minus x is 2x plus 1 squared. Here, h of f of -1. Again, first, let's plug -1 into f. So we plug -1 in for x. That's going to be -2 plus 1 is -1. Then take that and plug it into h. So here we're going to put -1 in here into h. So that's going to be 4 minus a -1 squared. That'll be 4 minus 1. So that's radical 3. Okay? So that's how you work with composite functions. Now the last thing is we want to write this, we want to create a composite function. We want to say, what would you use for f and g if you wanted to end up looking like this when you did f of g of x? So this right here represents f of g of x. So what I look for is, looking at this, if you look at this, g is the inside part, f is the outside part. Or if you wrote it in the other format, this looks like this. G is the inside part, F is the outside part. So looking at this, what's the inside part? Well, that in parentheses could be the inside part, so x minus 2. Now for the outside part, what are we going to do to that x minus 2? Well, it looks like we're going to square it, and then we're going to put it under 1. So there's on my inside part. What am I going to do to that? I'm going to square it and put it under 1. Well, if you look, if we put x minus 2 in here for x, wouldn't we get 1 over x minus 2 squared? There's other possibilities. The inside part, what if you said the inside part was x minus 2 squared? Now what are you doing to that? Well, aren't you just putting that under 1? So if we put those together, if we plug G into F, wouldn't we get the same thing? So that's why you could create composite functions.